Hey, how you doing? My name's Elton and welcome to the Container Show. So this is my weekly show where I talk about all things Docker and Kubernetes and container ecosystem and patterns and practices and anything to do with containers really. So the theme this month is all about service mesh. If you saw last week's episode, that was ECS-M1. That was all about the kind of concepts, the pieces that work together to make you a service mesh, what it does for you and what it can bring to your applications. The rest of the episodes this month are all going to be about specific service meshes, and today we are looking at Linkerd. So Linkerd was the original service mesh. It started live really as a service discovery tool, and then it merged to have into all the features that you kind of expect to have from a modern service mesh. It's a CNCF project. It's super well used. It's really easy to get started with. So today, the usual format, if you're new to the show, hello. The usual format is mostly demos, a little bit of an introduction to tell you what we're talking about, and then I switch over and it's all demos from then on. All the demos today, we're going to cover how you install Linkerd, what it looks like, what the various bits are and what they do, how you deploy your applications, and how you kind of register them with Linkerd so that all the communication gets managed by the service mesh. And then we'll look at some of the features like how you do traffic splitting to do canary deployments and stuff like that. There's a ton of features in all of these products, and Linkerd is no exception. I'm not going to cover it in any huge depth. What I want to do is give you a real flavor of what it can do, and then hopefully you'll be able to work out if that's something that you want to kind of invest more time in. Okay, so I'm going to go and switch over to this camera here in order to do my demos. To do that, I need to pull down my green screen and tinker with my microphone. So while I do that, I've got like a 20-second advert. I'll be doing a new advert at some point. I haven't got around to it this week, but at some point I'll switch the advert out to something a bit less familiar if you're used to watching it every week. So I'll see you in about 20 seconds over there. You're watching Elton's Container Show with your host, that's me, Elton Stoneman. These shows are live, unscripted and unrehearsed, so if you like my style but you prefer something a little more polished, then you should check out my courses on Pluralsight. Pluralsight's an online training platform, and I've got tons of video courses on there that you're bound to find useful. And if you prefer to learn by reading, then you'll be interested in my books, Learn Docker in a Month of Lunches and Learn Kubernetes in a Month of Lunches, which are both published by Manning. And if you just want to see what I'm up to, then you can check out my blog. And now, back to the show. And here we are. Okay, so here are all the documentation. If you go to eltons.show/ECS-M2, that will tell you, that will give you the kind of the HTML version of this, but all the markdown is in GitHub, in my GitHub repo, 6side/ECS. Everything that I'm going to do, you can do yourself. I write it down here. I've got some prerequisites. All you need here is Docker Desktop, because that's got Kubernetes with it, or any other Kubernetes deployment. So Linkerd sits on top of Kubernetes, works with the Kubernetes API to give you all your features. And up here, we've got a few links for today's show. So I'm going to be talking about Linkerd. So there are the Linkerd docs, which are really good. There's a really nice feature that you can do. There's a nice walkthrough on the documentation about doing GitOps with Linkerd and Argo. And I did an episode about GitOps and Argo a little while ago. So ECSC3, that was my episode about GitOps. And this document here is really interesting to read. If you come to this show and you didn't get the kind of grounding that I did last week, then have a look at ECS-M1. It's the same format as the YouTube show, but I talked about the architecture of a service mesh and what the features are at a higher level before we started digging into stuff. And if you don't know me very well, my name's Elton. I do this every week. I do a lot of Pluralsight courses. I do kind of container consultancy and training and a lot of video courses. So I did a video course about Istio, and I've done a .NET course for people who are just getting into containers from a .NET background. That's a Udemy course. So those links are just more plugs for you. Okay, enough plugs. So the Linkerd toolset kind of comes wrapped up inside this command line. So the Linkerd CLI is what's going to deploy it to your application cluster, to your cluster. It's going to let you work with your apps that are running through the mesh. It kind of takes care of the control plane management for you. I've already installed it, but it's a cross-platform tool, so you can install it with a package manager on Windows and Mac, so Chocolatey or Brew, and it's just a binary, so you can install it on Linux just by downloading it. So I've already done that. Linkerd is going to talk to your Kubernetes control plane, so it uses the same authentication that you've got with kubectl. So you're going to be using your kubectl credentials, and Linkerd will just kind of pass through that. Okay, as same as always, everything I'm doing, all the YAML files and everything, it's all in the GitHub repo, so you can check it out here. And I'm going to close this down now and open up my terminal. I need to move that over to the right. No, I moved it to the left, didn't I? Because that's better, because then you see my head. It doesn't get in the way of the commands. Okay, so first of all, let's make sure I've got the Linkerd command line installed. So this is just a little tool that helps you work with it. What Linkerd actually does, everything that it deploys for you, everything that you work with is inside Kubernetes, but the Linkerd command line just sits on top and kind of makes it easier to work with. So I'll also make sure that I'm connected to the right cluster, because I've been using lots of different ones this week. Docker Desktop, that's looking good. And Linkerd has these pre-flight checks. So just like when you deploy Kubernetes with the kubeadm tool, it kind of makes sure that everything's there, make sure you've got some kind of container runtime and all that stuff. Linkerd has a whole bunch of prerequisites that it needs to be able to do, and that check just does the pre-flight checks to make sure it's all good. And any kind of modern Kubernetes deployment, everything will be good there. And the next thing we can do is we can go ahead and deploy it. So Linkerd runs as a distributed application inside Kubernetes, so you can kind of have your own YAML file, but you can generate that for you with the Linkerd command line. So if I do Linkerd install, that's going to generate the YAML. I'm going to capture that in a file, and we can have a look at that. So there's a whole bunch of stuff it's going to generate for me. There are several different kind of flavors of the installation. You can configure how you want it to be deployed, because the default installation will include like Prometheus for metrics and Grafana for the dashboards. If you've already got your own monitoring subsystem inside Kubernetes, you can tell it to use that instead. But this is just going to give me the kind of default. So let's close the terminal down and have a look at this file. So here's my Linkerd YAML file. The reason that you use the command line to work with Linkerd and to deploy it is because you've got like 3,500 lines of YAML here, and you might as well let the Linkerd team work out the best practices for deploying it for you. So I'm just showing you this to show that it is just ordinary Kubernetes objects. Linkerd extends Kubernetes API using custom resource definitions in the way that you would expect the kind of service mesh to do. And but actually it's all just running kind of as Kubernetes objects and Kubernetes pods. Okay, so let's go back to my terminal here. So I've got my huge YAML file that I'm not going to spend any more time looking at. I'm going to deploy Linkerd just by doing a kubectl apply. There's William. Hey, William, how you doing? Okay, so kubectl apply, nothing unusual here. It's going to deploy a ton of stuff for me, but again, the way that stuff has been compiled and spec'd out inside the application manifest, that's provided for me by the Linkerd team, who wrap it up inside the CLI. So it's a really kind of super smooth deployment and upgrade process. There's a ton of stuff that's been put inside there. If I look at my namespaces, we'll see it's in a custom namespace. So now I've got this Linkerd namespace, and if I check what's going on inside there, I can get all the objects, and we'll see how this stuff actually runs. So there are various replica sets that are doing things. If we look at the deployments and the pods, a whole bunch of stuff that's running inside here. So like a lot of complicated pieces inside there, but you work at a much higher level. You don't need to dig into that stuff unless you're kind of debugging or you're planning out a highly available cluster, which you can do with Linkerd as well. And then now that I've got those things running in Kubernetes, I can do a Linkerd check to make sure that everything is up and running. So again, that command line tool just smooths out the whole process, makes it super easy to get started with, make sure that kind of everything's up and running. So it's making sure that everything's there now, and the control plane, the pieces are all up and running. It's going to wait for me just to make sure that everything's there. So I think I'll reset my cluster, so maybe it's downloading some images, and we'll see it. Let's spin up in just a second. While it's doing that, we can have a look at what it's actually doing. So the control plane here, there's a ton of stuff, and it goes into a lot of detail about what all these pieces do. So if you remember the previous episode where I talked about things like admission webhooks, where the sidecar proxy gets injected, about initializing the proxy to set up all the configuration for you, all that stuff happens in these different components, part of the control plane. And everything's looking good here. Cool, good stuff. Okay, so now I have my service mesh deployed. I don't have any applications running in my Kubernetes cluster, and if I deploy an application, it won't automatically get registered with the mesh. So when you're looking at a service mesh architecture, typically people are kind of deploying it on a cluster where there's some other stuff already running. So I've got my applications running. I've got a new team who've got a new product that they want to bring into Linkerd. I don't have to have separate clusters for that. I can leave all my existing stuff as it is. Stuff only gets registered with the service mesh and controlled by Linkerd if you actually kind of explicitly bring it in there. Okay, so now I've got Linkerd running. The other really cool thing that we've got is we've got this nice little UI that shows us how it's all working. So if I do Linkerd, have a look at the services, there's this Linkerd web service. It's an internal service, so I can't kind of browse to that directly, but there's a nice little feature from the Linkerd command line that will open the dashboard for me. So I'm going to open a new terminal and do Linkerd dashboard, and that's going to pop open my browser for me. There's a really nice little way of just browsing and seeing what's going on inside here. And this is where you're going to use some of the discoverability that you get from having a service mesh where all of your components are talking to each other through that kind of unified layer. We'll be looking at this UI a lot during the rest of the session. So when I'm running my applications, we'll be able to see how they're talking to each other. You can do some really cool kind of debugging stuff to see what's going on in that kind of stream of communication between your components. And the UI gives you that kind of overview of everything that's there. Okay, so that's all looking good. And now I'm going to deploy my application. So if you've seen the demos before in these shows that I do, I always do these kind of rubbish demo applications just because it's super easy to focus then on the features rather than get carried away with a flashy application, which I'm probably not going to be able to do a flashy website anyway. So let's go and look at my Widgetario app that we've already seen before. So let's clear this down, make sure I'm in the right place. Yeah, I'm in my demos folder. So my Widgetario app, I'm just deploying the application. There's a couple of different pods. There's a web pod. There's a couple of backend API pods. There are services that tie the whole thing together. This is not being registered with Linkerd. It's not doing anything to do with the service mesh. It's just sitting on its own. So I've got one namespace for my application, one namespace for Linkerd, and they're not touching each other. They're just separate apps as far as Kubernetes is concerned. So if I go and look at all the things that I've got running inside my Widgetario namespace, I'll see I've got my deployments there for my different components. I've got my services. Where are my services there? Oh, I don't get the services here. If I do the service list, I will see a load balancer for my web endpoint. So that's the entry point to the application, and the rest are cluster IPs. I'm not doing anything kind of special here. These are just standard Kubernetes things. You'll find all the YAML files in the GitHub repo. So if you go and check the app out here, let's see if it actually works. Phew, that's good. Feels definitely like you get hotter when you're demoing if you don't think it can work correctly. Okay, so there's my great logo for the Widgetario company, and they're selling bits and pieces. All this stuff comes from the backend APIs, and the stuff from the backend APIs comes from the database. So in order to see this, everything must be talking together correctly. All the authentication must be happening at the database layer and the API. So everything's kind of looking good. Right now, nothing's happening with Linkerd there. So if I go back to the Linkerd UI, and we will see if I refresh this and zoom out just a little bit, I can see the namespaces. So I can go and look at the Widgetario namespace, and there's nothing kind of useful in there. I can look at the pods. It knows about all the pods, but it says that they're not meshed. So I don't get any of the useful information about things like, what's the success rate of the communication between my components? How many requests per second am I getting, and what's the latency? I don't get anything right now because Linkerd knows about it because it talks to the Kubernetes API, and it's been informed about all these things that exist, but they're not part of the mesh. They're not automatically enrolled in the mesh at the moment. Okay, so the next thing we can do is we can add those things to the mesh. There's a couple of different options for that. You can kind of manually inject the settings that you need using the Linkerd command line. So you say, here's my YAML, go and add all the pieces that I need to it, or you can use automatic registration. Automatic registration just says at a namespace level or a deployment level or at a pod level, you add an annotation to your object that says anything that you find inside here should become part of the service mesh. And then when Linkerd sees those things being created, then it automatically injects the sidecar for the proxy and configures the proxy and all that sort of stuff. But there's a couple of things you need to bear in mind if you're going to take that approach. So firstly, if I look at my namespace here, this is the namespace that I've already deployed for my Widgetario application. This is the annotation that I need to add. So the kind of naive way is saying, well, everything's running in that namespace, so I'm going to deploy this, and then everything will get added to Linkerd for me, which is, as we're about to see, that doesn't quite work like that. So if I do my deployment here, let's just check that everything's working correctly. So if I look at the pods, what we can see right now, every pod has got one container running. So that 1 out of 1 tells me that it should have one container. That's what's in the spec, and one is up and running. So they're all looking as expected. If I run that update to deploy my namespace change, what that's doing is it's adding that annotation. So that means that anything that gets created there will have the Linkerd proxy automatically injected and registered with the mesh, but it doesn't act kind of retrospectively. So it uses an admission webhook to inject the proxy details, and that only triggers when something gets created. Now, by deploying a change to my namespace, that doesn't trigger any updates to the pods that are already running, so I don't automatically get all those things brought back in. So just a little gotcha if you're new to this and you do your deployments in namespaces and you say, well, why aren't these things meshed? That's why. So the admission webhook works at a lower level. Updating the namespace doesn't trigger that. Anything new I create in this namespace will automatically get meshed. Okay, so what I've got here, in order to get around that, let's get rid of my terminal again. I've got an update to my API YAML file. I didn't show you these because there's nothing special about them. There's nothing to do with Linkerd up until this point. So inside here, I've got a deployment that's running my .NET container image here. It's just exposing a port and giving it a name. Nothing special there. And then here I've got the annotation, and that's part of the pod template. So by changing the pod template, that will trigger a replacement of the pod with a new one with the new configuration. And then Linkerd will see my annotation, and then it will bring that new pod into the mesh. So let's close this down. I've added that to all of my deployments. So we'll see when I run this new update, everything will get brought into the mesh. So let's do this now. So it's going to update all of my deployments, which adds that annotation. And now if I look at the pods, let's clear this and get some space. Now I can see that the update is happening, the rollout is happening. This is the one that's being closed down, the old products API that have one container, and the new ones all have two containers. So they're going to be, the second container there is the sidecar that's running the proxy. For the web container, I've got three. For the web pod, I've got three containers because I'm also running a debugging proxy inside there, a debug container, which is a really nice feature that you get with Linkerd. You can get that by adding an extra annotation. Let's get rid of the terminal because otherwise we've got no room. So inside here, this is for the web component. I've got my Linkerd injection to make sure it gets registered with the mesh when the pod gets created. But I've also got this enabled debug sidecar. And that adds another sidecar, which you'll only do in non-production environments with a load of tools like TCP tools and ping tools and network inspecting tools. So you can see exactly what's going on. You can connect to that pod, connect to the debugging sidecar container, and inspect what's going on with the traffic. Because one of the things you'll find as you start using a service mesh is that you've got these kind of centralized rules about your traffic. It's very hard to get to a low level and confirm that what you think is happening, the rules you think should be applying, are being applied. So that sidecar debugging container is really useful. Yeah, and as William says, you can use rollout restart. Of course you can, yeah. Okay, so let's open this up here. So now I should have all my pods. If I clear this down, check this out again. Oh yeah, everything's up and running now. So inside those pods, I've got my sidecar containers and that are running my proxy. And now that's owning the network communication. So if we go back here to my Linkerd dashboard, and now if I refresh, we've already seen all these, they're all meshed. So that's looking good. So now they're all part of the communication. There's still the details are still empty because I haven't sent any traffic through yet, but it's all being monitored now. All the information is being collected by Linkerd and it will all be surfaced through this UI. If I go and look at the namespaces and check out my Widgetario, I've got some links here, the things that I particularly wanted to show you. So there's my Widgetario namespace. If I look at the website, let me do some refreshing here. So now when I make these calls, application behaves in exactly the same way. The end user experience is the same. The components within Kubernetes are the same, but now the communication between my components is being routed through the sidecar and the proxy rules are being applied. And that's completely independent of my application configuration. So now that I've sent some traffic through, let's just refresh again. Okay, now we can see the kind of live service mesh. So we can see there's my web component. There are various things that are fetching traffic from the web component, which are to do with Linkerd. So the communication to Prometheus that's collecting all the metrics, but we can also see my backend communication to my products API and my stock API. So we can see that all those requests have been successful, number of requests per second. This is the live map. So it's going to fall and fall and fall because I'm not pushing any traffic through. I could run a nice little load balancing tool and we would see these figures all jumping about, and that would be kind of more useful. And if I look at the deployments here, I can see that kind of low level thing that's telling me it's meshed, and I can get all the details here, the routes of what's going through. And again, this will show me the more traffic you've got, the more useful this view is. So I can see all the latency and all that sort of stuff. So really kind of nice overview of what's happening inside my application, where the inbound traffic is into my web component, which is the Linkerd metrics collection, and the outbound going to my products API and my stock API. Okay, so all kind of nice way to get that observability around your application with very little change. So I haven't changed any of the configuration of the endpoints where my applications are talking to the components. I haven't changed anything to do with the services. I've just changed that one line to enroll those components with my Linkerd service mesh. Okay, so now the thing to do is show you some of the features. And we're just going to really kind of lightly skim over the main things that people are wanting to use a service mesh for, the main things that I covered last week when I talked about the architecture of this. One of the most useful things is having automatic elevation of plain text communication to encrypted. So right now, my backend APIs that get the stock information and the product information, they're REST APIs, it's plain text, it's just a pure HTTP communication. So nothing's being encrypted, nothing's being kind of authenticated. But now that as soon as I enroll them with Linkerd, I get automatic mutual TLS. So that means that when the web component makes a call to the backend API, it presents a certificate so that the backend API can tell who it is, and then the backend API has its own certificate, and then that whole communication is encrypted with TLS. so that so you can't observe it, you can't hack around with it, but you don't have to manage the certificates yourself. So that's the kind of difficult part about encrypting all your traffic, is that it really kind of breaks the developer workflow, because you either have developers who are kind of managing self-signed certificates, and that all kind of gets out of hand, and then when you get to production, you have to roll those yourself, and you have to make sure that you only generate short-lived ones, and then update them when they expire, and all that sort of stuff. So having this central component that generates the certs for you, applies them, rotates them when they need rotating, that's takes care of all the kind of management layer. And we can see exactly what's happening there. So if I grab the IP address of my pod, one of my pods here, so this is the stock API. It's just one of the back-end things that tells us how many components we've got available. I can see the IP address here, so that's the IP address of the pod. So not of the service, this is of the pod itself. So that's another important thing. Let me just go and grab that on a screen that you can't see over here. Yeah, let's just copy that in so we've got that available to us. And then I'm going to go and exec into my Linkerd debug container. So this is my deployment for my web component. So my web component has got the sidecar container for the proxy, but it's also got the debugging container, which I applied with that other annotation. I'm going to go and connect to that container now and just exec into it so I can run some commands. The first thing I'll do is I'll make sure that I can actually get to my stock API. And I do, that's the response that the website sees. This is all happening through the proxy. So remember, inside my pod now, I've got 3 containers. My application container that's receiving the traffic from the outside world, asking it to render the website. I've got the Linkerd proxy that is actually doing the network proxy. Linkerd, the proxy component in Linkerd is a custom component. It doesn't use Envoy like some of the other service meshes do. It's got its own proxy written in Rust. It's super fast. It's all open source. You can go and check that stuff out. Any calls that I make within the pod, within the environment of the pod, are going to go through the proxy. So my debug container is seeing that too. Okay, now if I go and do inside my debug container, I've got this tool called T-Shark, which is like it would be good if I actually copied it, which is like a command line version of Wireshark. It'll show you what's going on at the low level of the communication between your components. So what I'm going to do is I'm going to run T-Shark, and I'm going to listen on my network device for any communication to the pod that's going to be my stock API. It's going to sit there for the moment, so I'm telling you it's port 80, which is the port that we use, but I'm looking for SSL traffic here, and if I go back to my web application, I'm going to move that onto a different screen so we can see what's happening. I'm going to refresh lots of times, and what we'll see is there's a whole bunch of stuff going on here, and it's going from my web pod to my stock API pod, and it's TLS version 1.2. And you can see that the actual communication that I use, this is the URL that the website uses. It's plain HTTP. I'm not using any kind of the hosting inside the stock API is plain HTTP. There's nothing happening with certificates or anything there, but I'm getting Mutual TLS purely because that all gets layered on for me by the service mesh. So I get that stuff in there. It's really nice and easy to have that encryption in transit without having to configure and manage it all yourself. Okay, cool. So we can just prove that that's working really nicely. The other thing we can do is make sure that it doesn't break any existing components. So what Linkerd does is it says, if I've got these 2 components that are both in the mesh, if they're talking to each other, then I can upgrade that communication to Mutual TLS. I know it won't break anything because that's that's a low kind of network level implementation. The applications just see everything working as before, but it's now the communication channel is running on TLS. But if I have a component outside of the mesh that wants to consume that same service, it can't use TLS because it's not part of the mesh, so it can't have the certificate applied. It doesn't have the proxy running, so it doesn't have the rules applied. But rather than break that communication, Linkerd lets that pass. So the TLS upgrade is optional. It's there if both components are part of the mesh, but if the client or the server is not part of the mesh, then that upgrade doesn't happen. So the application kind of still works if there's some other component that needs to access it. And we can check that too. So if I clear this down, I've got a really simple pod that I run here that's just going to run a sleep. It just sits there and I can go and connect to it and do stuff with it. This is running in the default namespace, so different namespace from Wiretap. That namespace doesn't have the annotation, so this sleep container is not part of the mesh. It's just one container in the pod. There's no proxy, there's no TLS, there's nothing. I can do an NS lookup here because in Kubernetes, services are cluster-wise. So if I include all the fully qualified domain name to get to the stock API service in the Wiretap namespace, then I should be able to go and resolve the IP address. The IP address is the service IP address, which is not what Linkerd uses. So Linkerd is maintaining its own list of endpoints that are available, and it goes directly to them. So it kind of bypasses the service. And I can make sure that I can actually go and check that. Oh, you see, now I should need to get used to running it clear. Inside this sleep container, I've got wget, so I can make sure that I can go and get the details, and it works in the same way. This is a plain text HTTP communication channel. So that's what the server expects, that's what the client expects. There's nothing in between that can upgrade it for me. Now, what you can do is you can, in other service meshes, you have the option to enforce TLS to prevent any other components that are not part of the mesh making that communication. So you can say, as part of your configuration, these are going to be mutual TLS, and it's not optional. It has to happen. If you're not part of the mesh, you can't access this component. That's coming in Linkerd. So there's a couple of there's a link here which will take you to a GitHub issue which mentions that, and also the ability to do authentication and authorization. So the way that the mutual TLS works is certificates are bound to the service account where the pod is, the context that the pod is running in. So in Kubernetes, you have these service accounts, which are authentication mechanisms. Because the Linkerd container is running as part of that pod that has the service account token available, it can generate a certificate that's linked into that service account. And that would enable then authorization. So you would be able to then say that the Widgetario stock API can only be accessed by the Widgetario web component. And as well as enforcing TLS between those components, you would enforce authorization. So if any other component, even if it was part of the mesh, tried to access the stock API, it wouldn't be able to. Can't do that right now, but that's coming. We're at version 2.9 now of Linkerd. I think that's coming in 2.11, so it's planned in down the line. Okay, so that TLS stuff, like that's it's quite a low level thing, but it's really important to have that functionality. It means it doesn't matter where your containers are running and where your pods are running across your cluster. The communication between them is always going to be encrypted, and you don't have to do anything to make that happen. Like that's a kind of super easy way to bring your security up to a more resilient level. But one of the more user-facing things that you get with the service mesh is this idea of traffic management, splitting the traffic because the mesh owns the actual communication paths. My web component can be talking to some downstream application component, but the service mesh is actually going to decide where the traffic really goes. And for that, we'll look at doing a traffic split for a canary deployment. So if I close down my terminal, actually I'm still inside this container, so I better leave that container, otherwise I'll get thoroughly confused. And then I will close my terminal down. So for the traffic split idea, which is going to power blue-green deployments where you split entirely from one to the other, or canary deployments where you gradually shift traffic from your version 1 to your version 2. For that, Linkerd uses the service mesh interface, which I talked about last week, which is this idea of taking some of the core concepts that all the service meshes do and abstracting them into a separate interface. So you can when you're defining your application, you're defining your deployments, you work at a higher level than your actual service mesh, so you don't have to worry which service mesh implementation you're using. Linkerd uses that for the traffic split stuff, and it's a really clean, nice way of defining your traffic split. The way it works with the service mesh interface is that you need multiple services. So I'm in Kubernetes. So I've got a Kubernetes service, which is the domain name of the target. So I've got, my products API, and that's the domain name that my consumer is using. So my web component, when it goes and fetches all the list of products, is going to go to http://products-API. That's my kind of SMI calls that the root service. And then underneath that, I've got my different implementations. So, I maybe have my blue service that's pointing to my blue deployment and my green service that's pointing to my green deployment. And I will use the traffic shift to say, to direct the traffic from this is your target, which is your root domain, but you're actually going to get the traffic from here. Let me show you how that works because it's probably clearer to see it in the YAML, which is a phrase that no one's ever used before. So here's the services that I'm talking about. So this is the products API. This is the one that already exists. So when I deploy this, this won't change. I'm just showing you that all the services are in one place, makes it kind of easier to get your head around. So the metadata here, that's my domain name, products API. The selector is my app, the products API app, and that's all I've got. That's what's currently deployed. When I start to deploy my new version, what I'm going to have is my ultimate services where the traffic is really going to go. I'm going to have my products API v1, which is selecting based on the application name and on the version. So what I'm going to do is I'm going to deploy two versions of my products API. V1 is the existing version. That's where all the traffic is going to go when I start off. And then gradually I'm going to shift traffic to my V2 deployment. And I do that with these separate services. So the service for my V2 deployment Again, it's a separate service. It's got its own domain name, and it's got a separate selector. So it's going to pick from the pods that have these labels. So it's the product API component, and it's the V2 deployment. And then when I've got those in place, then I can use my traffic split custom resource. So this is part of the CRDs that get deployed when you install Istio. When you install Linkerd from your command line tool, you get a whole bunch of CRDs. This is one of them, and as you can see, it's an SMI spec CRD. So this is a custom resource that's built from the definition that comes in the SMI. It's called a traffic split, and this defines the targets of where things are actually going to go. So this says where are people trying to find the root service, where is the destination that the consumer is trying to use, and then the back ends of the actual destination. And what I'm saying here is I've got my service V1, 100% of traffic is going to go there. I'm also got my service V2 in here, and I'm saying zero traffic is going to go there. Kind of redundant to have that, but it makes it clear if you're looking at these specs that I have two potential destinations, and 100% of my traffic is to start with going to go to one of them. Okay, let's close this down and open up my terminal again. The way this is done is you can deploy these kind of changes without breaking your application. So I don't have any V2 pods running at the moment. What I'm going to do is I'm going to deploy my services first of all. So that's going to do my products API service, the top level, the root service, the one that the consumer is using, and my two new services. Right now, I only have V1 components running, so even if I try to send traffic to V2, there aren't any containers that are running there. So now I can deploy my traffic split. And again, this is not going to break the application. So the traffic split here is saying, I know about the V2 service, but I know I'm not going to send any traffic there. So when people are using this, then they're not going to be trying to use the V2 component. If I refresh this, we'll see that everything is coming from V1. V2, the prices increase, so we can check that out pretty easily. Everything's coming from V1. These are the same pods. Like that, we're not doing any kind of new deployments here to spin up new pods for this. I'm going to spin up some new pods in a second for my V2 deployment. So right now, all I've done is got the kind of pieces in place to enable me to shift traffic in between my components. But right now, that traffic shift is pushing everything to my existing V1. Okay, so let's have a look at this. The next thing I'm going to do is I'm going to deploy my actual my V2 deployment here, which changes the prices that the product API sends back. And what we can see here is it's a separate deployment. It's got those labels, the product API application label and the V2 version label. So the V2 service will direct all traffic to here. And then way down here, it's the same image. It's just got this nice little feature that lets me increase the prices by whatever factor I choose. So nice little config setting in there that's going to elevate the prices a little bit. But I can do, if I'm kind of maybe thinking that I want to hike my prices, but I want to check out to see how well that's going to go down with people, I can just send a small number of people to the higher value API that's going to show the larger prices, and I can check out to see whether people still buy at that price. Okay, so let's go and have a look at that. And then when I've deployed that, I can change my traffic splits. When I've got my backend deployment with my version 2 containers running, I can change the split to say I want 70% to go to version 1 and 30% to version 2. And the more traffic you get, the more you'll hit those kind of target figures. But what we're saying is roughly like what 1 in 3 is going to go to my new service. Okay, so let's go and deploy this, see how it looks. So I'm going to deploy my new components first of all. So that's just going to create my pods that are running my newly configured products API. And then when I run so far, nothing's happening. So my traffic split is still 100 to 0 to version 1. So I'm not going to see any prices coming from version 2. But now when I deploy my split to 70-30, what we'll see is the only thing that's been updated is that traffic split object. I haven't changed any of the services or any of the deployments. So you can do this and tweak this as much as you want to without changing your actual application components. Now when I refresh, so if we have a look, my system on a chipboard is $30. If I refresh, it'll mostly be $30, and then every now and then it'll jump to something bigger. There we are. So this has now come from version 2. So if I was a happy user who hit this, I might not want to go ahead and purchase. But if I refresh, then I'd see version 1 prices coming through again. This is a really simple traffic split policy, and you can include more interesting stuff like different user agents to send people from different browsers to different endpoints. You can track things with cookies and all that sort of stuff to make sure that when users see one particular version, they carry on seeing that in the future. So really nice kind of way to get that stuff done. And of course, you can see all that in the UI as well. So if I browse to here, we can see my traffic splits. So I can see my products API. The name of the traffic split was the canary. I can see both the target endpoints here. So the apex service, the root service, the destination that people are trying to use, that's the products API service. The leaf service is the actual target that they're going to get to, which is either version 1 or version 2. And there's my 70/30. And I can see that every call has been successful. Those are my requests per second. So there are a lot more for version 1 than there are for version 2. And if I had the stats, I would see all the latency stuff as well. So I get that level from the UI showing me how these things are all working and showing me the traffic that's going through my components. Okay, and there's a lot more you can do with traffic management, so I'm not going to cover it today, but there's some good links in here if you want to go and check out some more detail. Linkerd has this idea of service profiles, which you can attach. They're separate objects. You deploy them in your cluster, and they kind of reference a Kubernetes service, but they give Linkerd a bunch more information about what that service does, and you can configure a profile so to change the behavior of what goes on inside there. And that's how you get things like monitoring for each individual route. So your service profile kind of tells Linkerd the routes that you're interested in, the HTTP paths that you're interested in for a web application or gRPC, the calls that you're interested in monitoring, and you'll get more detailed stats per call. And it's also where you do things like the retries and the timeouts. So because your network communication is being managed by the service mesh and configured by the proxy, if there's a failure from my web component to my backend API, I can configure that in my service profile to say, just retry it once or twice, and then retry it with 10 seconds in between, exponentially adding some time, and don't retry more than, however many times you want to do that. You configure all that at the service profile level. So it's independent of the services themselves, and of course there's no application code, and you don't include that in your application modeling. So you've just got stock deployments, stock services, and alongside that you can have things like your service profile and your traffic split to control the traffic. Okay, and you can also do the functionality that we've seen. You can do that same kind of stuff for the entry point to your application. So if you're running an ingress controller and all your traffic is coming into Nginx or traffic or whatever you're using for ingress, you can have your ingress as part of your service mesh too. So the ingress controller has a proxy, and so when it's fetching traffic from the upstream, which would be your web component, you can apply the same kind of rules. You can have those same retries and timeouts with the profiles. You can do that same kind of traffic split. So you're not limited to just internal network traffic management here. You can bring it all the way up to your ingress components too. Okay, so we're kind of getting to the point where we're running out of time. That's fine because I've only got one more demo left. So observability is kind of one of the main things that people are interested in when they move to a service mesh component, especially like I've got a really simple demo application with 3 things that talk to each other. But if you're running a proper microservices application with dozens of things all communicating with each other and with their own backend databases and with, canary deployments going between different things, it's very hard to get an overall picture of how these things fit together, and your service mesh can give you that. And it gives you that kind of, with Linkerd, you get that lower level insight into what's actually happening between your components when they communicate. So what we can do is there's a whole bunch of things in the Linkerd command line. So if we run Linkerd stat, it'll tell us what's going on from my product's canary. So I can just see the details of the same thing that I saw through the UI. But of course, I can put all this into a command line and script it and do whatever I need to do. So it's telling me about where the destination are, where the leafs are, and the current traffic split. So I can see how things are currently deployed. If I look at the edges, it will show me how these things are all connecting together. So I can do this at the namespace level. Oh, I've just got a whole bunch of stuff here that I didn't intend to see. So let me try that again. So at the namespace level, I'm saying for everything, all the pods in the Widgetario namespace, show me how they're all kind of connecting together. And I can see here that I've got my my products DB that's being used by the API. I've got my stock API in here. Everything that's kind of, it shows me the kind of details of how these things are, the routes, the things that are communicating with each other. I'm skimming over some of this stuff. It's something you will spend a lot more time with. And then one of the other things that's really good, which Linkerd I think is unique in having, is this idea of being able to do like a wiretap of the communication between 2 components. So again, it's a feature of the CLI. You also get it through the UI. So I can do this Linkerd tap command. I'm saying what I want to do is I want to tap the communication from my web component. Every time it talks to the stock API, I want to see what's going on inside there. So it's just like having a wiretap that's just listening to that particular channel, and it will show me all the communication that's happening. So if I go and start up my tap here, I was going to just sit there and wait for traffic to go past. So if I go and browse back to my application, again, I'll drag it to a different screen. as I'm refreshing, we will see all of the traffic going through there. So I can see the method is get that's talking to the stock API. I can see the paths that it's working with. So I can see that it's not very efficient the way my application works. It makes 3 different HTTP calls for the different stock items that it's using. I can see that it's TLS. I can see the response status. I can see the latency in microseconds. So I get a real low level of detail about all the things that's happening there, which is obviously really useful if you're trying to debug a real life problem. So in production, you won't necessarily have your sidecar debugger attached. That's something you're going to use in your non-prod environment. But if you're trying to track down an issue between 2 components and you just want to get a dump of everything that happens inside there, you can do it with your tap command, and then you can inspect all those things and work out, is there latency going somewhere? Are there more calls happening than you expected to happen? All that sort of stuff. So super useful stuff. Okay, and then the other thing that I talked about last week is and the series before is when I talked about monitoring with your containerized applications. I talked about distributed tracing, kind of that idea of having really the historical audit of all the communication that happened between your different components and being able to piece together an end to end and break it down. We looked at Jaeger for that back in ECS-V4, and I talked about how you can integrate that with your service mesh. And again, I won't demo it here because it will take a little bit too much time, but there's a whole document that tells you how to do that with Linkerd. So same kind of principle. Inside my applications, I still need to have those HTTP headers. So remember that it's easy enough to send the information about your network communication to Jaeger, but it doesn't know that that particular call is part of a wider transaction. So the pieces here are you need to have something that initiates like a correlation ID at the entry point to your app, and then all your other components. So you need to have these HTTP headers, which is just a relay that say, if an incoming call has got this correlation ID and a bunch of other headers, then I'm going to add them to my outgoing calls. And that's all you need to do. So you don't need to have a reference to a Jaeger library or anything like that inside your code. You're just passing those HTTP headers if you find them. So it's a fairly small code change that's not invasive in terms of the amount of code you have to write or the dependencies you take or the amount of CPU time you add. Once you've got those things in place, then Linkerd will act as a collector. So Linkerd will collect all those stats and it can forward them onto Jaeger. So you get that same end result that we've seen before with that nice Jaeger UI that shows you the distributed call for all of your different components. But all you've had to do is write the headers inside your code and then configure Linkerd to talk to Jaeger. So it's kind of all super nice for you. Okay, so that's the very quick view of Linkerd. So Mike said, why would I choose Linkerd over Istio? That's what this whole month is about, Mike. So Linkerd has a couple of things that stand out. So that UI, there aren't alternatives in that in some of the other service meshes. Other service meshes tend to give you, several different things. So like with Istio, you'll use Kiali, which is the observability thing in terms of seeing your service architecture, and then Grafana for your stats and all that sort of stuff. Linkerd has that in its own UI. Has some of those features like tap, which I think other ones don't have. And there's things like performance. So if you really drill down, if you're doing tons of network communication and you're pushing it all through your service mesh, then the CPU overhead of kind of going through the proxy for everything can take its toll. There's next week, I will show you when I get to Istio, I'll show you a link that one of the guys at Shopify put together a detailed look at the cost, the CPU cost of running Istio for a large deployment, of having to have enough extra power to power all those proxies and all the stuff that you want to do inside the proxy. So performance is another one. And then the other point is the kind of the management of the project itself. So Istio has this kind of murky background where it was jointly developed to start with by Google and IBM. There was this kind of gentleman's understanding that it was going to be donated to the CNCF and that was going to happen, and then suddenly it didn't happen, and it didn't get donated to the CNCF, and that made a lot of people quite nervous in terms of the long-term goals of that project, because if it's a CNCF project, then it's really hard for one company, one vendor to steer things the way they want to. And if it isn't a CNCF project, then it's easier for that to happen. Now, that hasn't happened with Istio. It's carried on being a community project. It's still very highly used. It's not kind of taking a deliberately googly direction, but a lot of people are nervous about where it might go in the future. So Linkerd is a CNCF project. So you've got all these things in there. Look at your performance, look at the ease of use. When we look at Istio next week, there's a lot more stuff that you can do, but you do that with a lot more YAML. So you're going to add tons more YAML. And then think about that kind of, does the openness of it matter to you in terms of the foundation? And to some people it will, and to some people it won't. But there's a few different factors there. So next week we will look at Istio. We'll do a similar sort of thing, like a lightning quick run through of deploying it, seeing the major features, seeing how you configure them, and then the final week we'll look at the open service mesh, which is a kind of full SMI implementation. And by the end of that, then you'll have an idea about how all these things work, how you can compare them, and whether they're for you for your next deployment. Okay, so that's it for this week. Thank you very much for joining. Thanks very much to William from Linkerd for joining in too and not hassling me and pointing out that I was doing too much wrong. And I will see you next week where we'll do the same stuff all over again, but we'll do it with Istio. Thanks.